Hello and welcome to the third tutorial in the FTC Nova Android programming Android Studio tutorials. Um, so last time we went through sort of the basic structure of a teleop program, and we had our robot move forward if we were pressing the A button and stop otherwise. And the next logical step would be, well, how do we create a basic autonomous program? And creating an autonomous program is very similar to creating a teleop, with only a few changes, like changing some words and a little bit of tweaking to the structure. But otherwise, this knowledge here is is basically exactly the same as the knowledge you need for autonomous programs. So we're going to create an autonomous very similar to how we create a teleop. You right click op modes again and do new Java class. And let's call this autonomous tutorial 1. Alright, so in here we are extending op mode, and op mode is the class they use that Qualcomm created for teleop mode. We need to extend something called linear op mode, which was created for autonomouses. So we're going to do extends linear op mode. And linear op mode, the word linear means that it runs it once. So in op mode, we had a loop that runs over and over again indefinitely. In linear op mode, we're not going to have a loop. We're going to have sort of a sequence of instructions that runs once and then stops, which is exactly what an autonomous kind of is. It's only 30 seconds long, and there's a sequence of moves that it needs to do to get where it needs to be. So this makes sense. And then we need a constructor, just like last time. That doesn't really do anything, but Java needs it. And then sort of fill it in, get our brackets all set up, and then we're going to override functions again. This time it's a slightly different function, so we don't have init and loop. We just have one function called @override, and you can sort of see it right here, run op mode. And this code here is very important. Basically, when it says throws interrupted exception, this basically just is telling Java how it can go wrong. You don't really need to be concerned about it and what it's actually doing. It just needs to be there. Otherwise, it will not compile correctly. So run op mode is the name of the function of the code that just runs once. It goes instruction by instruction and then stops. And so we need to, just like in teleop, we need to declare what motors we have and create variables for them so we can use them in our set of instructions for autonomous. So let's say we have the same robot before, it just has 2 drive wheels. So let's create our wheels. Public DC motor right and public DC motor left. And so we assign them to motors in our init function, and we need to assign them to motors here, but we can just do it at the beginning of our set of instructions because that's going to run before we try and move anything. So, and it's only going to run once, so we're not like doing some weird stuff of assigning it like 3 times. It's just going to run once, and it's going to run before everything. So we can put it right in here. So right equals hardware map .dc motor .get quotes right. And then we do the same for the left. So right now we've declared our motors again, just like we did in teleop for autonomous. Alright, so what do you want to have our autonomous do? Well, let's say we're playing the rescue game and we just want our robot to drive forward and go into the parking zone. How do we do that? Well, we need to have it drive forward, so we're going to have to give our motors power. And that's probably the first thing we're going to do when we're moving. So let's, it's just the same it's just the same lines that we're doing here. So let's set our powers for our motor so we're moving forward. Right.set power to half, and then remember the left has to be opposite. Oops. The left has to be the opposite power because it's flipped around on the left side. And so this line will have it run forward. But remember, this is just going to run through here, and then once it reaches the end, it's going to stop. So if we ran this program right now, it actually wouldn't do anything that we can tell. It does do some stuff. You just can't see it doing anything because it's going to give them half power, and then as soon as we've given the left motor negative half power, it's going to get to this next line and say, oh, I'm done, and then kill the program and everything stops. So you won't see anything happen. And so we need to be able to tell the phone, hey, once you have assigned these, I want you to keep those motors running for 3 seconds so I can get as far out as I need to be in the parking zone. And we can do that. Telling a phone to wait for the programming language Java can also be used as the word sleep. And so sleep is a function that was written by Qualcomm to do specifically that, make the phone wait for however many milliseconds that you need. So if you type in the word sleep, and then you put in the little normal brackets however many milliseconds you want it to sleep. So if you want a robot to run for 3 seconds, 3 seconds is also 3,000 milliseconds. So if you type in 3,000, this line's of code, what it's doing is, so here's what the phone's going to do. It's going to start here, read this line, say, okay, my right variable motor is the right motor in the controller, and then the left is the left. Alright, and then it's going to go here and then assign the right motor power a half, and then assign the left motor negative half, and then it's going to get here, and it's going to say, oh, I need to stop for 3 seconds. So it's going to be stuck at this line for 3 seconds. And then since we assign these motors the power, it's going to stay at this power. So the robot's going to move forward at 3 seconds. So once 3 seconds have elapsed, the phone is going to move on to the next line. And now at the end of, once we've reached into the parking zone, we want our robot to stop and stay there for the rest of the autonomous period. And so just like as we set the power to 0 here in the teleop, we're going to set the power to 0 here so we can make the robot stop in the parking zone. So we got to do right.set power 0 and left.set power 0. And then it's going, so once it reaches these lines, it's going to have the robot stop. It's going to be in the parking zone, and then it's going to reach the end of the run op mode, and then the program is just going to stop, and it's going to sit there for the rest of autonomous. And that's really the whole story. That's all that autonomous really needs. I think autonomous is actually simpler to write than teleop in terms of the structure and the flow. Because you just have this, it does it, and then it's done. You don't have looping and stuff like that. It's just going to run these lines and be done. And so once you want to make sure that you actually do stop your robot, and even if you didn't have these lines in, I believe once the program sort of terminates, it will set the motors back to 0. But it's always good practice to make sure your motors are actually stopping properly. So yeah, that's creating a very basic autonomous. Next time we're going to get into some more complicated stuff, probably with encoders and different structures in Java that are very useful, such as the while loop and the for loop, and sort of different tools that we can use to make life a lot easier in programming, do some really cool stuff. So yeah, thanks for watching this tutorial, and I will see you